Excellent. Hello, everybody. As actually in northern Illinois, it's chilly, cold, blistery, windy. So I've got my sweater on, and I will turn off the webcam here shortly just for the purpose of ensuring a nice clean flow as we push all this through the World Wide Web. What I'll be focusing on today is multiple topics, not necessarily all related, but items that we run into on our support desk, and also things that we run into in training that can help our clients, and we hope this helps you also. If you can't stay for the hour, that's fine. It'll be recorded, as Ashley mentioned, and we'll get that to you. What I'm going to be covering today is ways to change the display of our CAM browser. Multiple settings there that I'll discuss. I'm also going to discuss the manipulation of your defaults and expressions. I believe Clayton, my colleague and friend Clayton, hit this on an earlier session also. We're going to hit it again and maybe expand just a tad, nudge, nudge on that. We'll get into the customization of the Inventor marking menu, and yes, we can customize that for HSM or InventorCAM, as they call it today with 2020. And if I just confused you there a little bit, with Inventor, with the 2019 release and earlier, it was Inventor HSM, and when they came out with 2020, they rebranded, renamed the product to InventorCAM. We're going to get into touch surfaces. We'll see this more in a surfacing environment. I'll hit that briefly. Manipulating the tool orientation is a big deal for a lot of our clients, and we run into this in both the turning environment and also in the milling environment. So hopefully time will allow me to show you both. I'll make sure and show you both, even if we run over, because it is important. I'll finish it off with a little short one on the Spun profile in turning. Won't take long, but it's very important, and a lot of people miss that switch. So let me turn off my webcam. So now you just see my picture, I hope. So again, we're going to start here with ways to change the display of your browser. I am now in the 2020 version of Inventor and InventorCAM. On the ribbon here is the CAM ribbon. Within the Inventor environment, we have tools for customization and so forth. I'm going to hit that a little bit later. But on the CAM environment, we have, on the far right, we have options that are available to you. And one thing to start with is, if I'm an Inventor guy and have been using Inventor forever, and I go and I work within the software and I go to produce a whole of some sort, the software pulls up in front of us a dialog box and leaves the browser exposed, which can be handy. When we go to the and I do an operation of some sort, I have my CAM browser here. When I do an operation or something, it actually changes the browser. So there's no pop-up dialog. Within the options and the user interface, there's a switch down here that says combine the operation dialog with the CAM browser. This is totally user preference. But if we turn that off and hit OK, then we'll have behavior that you might be more familiar with if you're an Inventor user. If I now go to an operation, it will pull up that operation in another dialog box. And what's nice about this is that the browser is still yours to use. So I can still go maybe plane if it's important, work access of some sort. So now by throwing that switch, you can kind of have your can and your design cake and eat them both. So again, that was under CAM options, the environment, and combine the dialog box with the CAM browser. Also, there's several ways that we can display this browser. Right now is pretty much an installed situation where we have Inventor, we have our up, and then we have our operations underneath it. You see drill 4, drill 8, you know, where does 4 and where does 8 come from? It's basically like Inventor where it just adds on a number. So even if you delete things, it's not going to resequence that. So it's always very helpful and highly encouraged that you actually select on an item in the browser. And if you do a slow, do two clicks slow. So let me start over. So if I go click, click, I can now change this to something that's more meaningful. I have 3 drills here. I don't know which those are. There's an axial, there's a radial, and there's a radial. So again, with the slow clicks, you can rename these. Another thing that's nice, and you'll find this again under options, where we were earlier with the user interface, there is a browser tab. And within the browser tab, we can control what is being displayed in the browser. For example, I could show the tool number and the tool compensation offsets. Probably more environment are the tool compensation offsets, but it does apply to both turning and milling. So if I OK that, you'll see now that we see the tool number being displayed, and also if the offset value is different, it will display that also. We can also go and do the tool description. And now it will display the description. So where are these fields specifically? If I go to the tool library, either by hitting the tool library icon here, or in my case, I'm just going to double pick one of these operations and go to the tool library via this method, hit edit. Here's the compensation value. And this is the description. Make that change. And now you can see that those values have updated appropriately. Back to options, back to the browser. We can also show setup work offset and spindle. And you'll see that up at the setup environment. We're using a work offset, which is the default primary spindle. I was pulling that right here. Back to options, browser. We can even show the cycle type, and we can get into the manual NC and show the pattern also. Excuse me. I'll turn those on. And now we can see here that the cycle type is chip break and the pattern is a circular pattern. So if we go and edit one of these operations, change the cycle type to perhaps drill and hit OK, you'll see that that changes. Circular pattern is here. Some people aren't familiar with manual NC, and some of this does depend on your post processor. But manual NC can be found at the top. You can also find it by simply right-clicking in your browser, and you'll find manual NC here. As a note, you can right-click in your browser and basically find everything that you can also find up at the CAM ribbon. Manual is basically to allow you, again, depending on the post processor, to control operations that are not found in your CAM ribbon. A couple very common ones might be a stop, where you want to throw an M0 out. You'll notice now that manual NC, because my options are turned on to show that, it tells me that it's a stop. I can go ahead and duplicate that with a right mouse click, and we can go to manual NC and add a comment. Check OD size. For a simple example, I'm using parentheses, which are common when sending text to a machine control. And now, because I have that switch turned on, again, under options, browser, it's actually showing me everything that's going on. That was a pretty quick way to talk about ways that you can display or change the display of your CAM browser. Briefly, we're going to hit the manipulation of defaults, and some of this we've discussed. I know Clayton did an awesome webinar, and you can find that on our website under webinars by demand, where he did get into the defaults and even elaborated more on expressions and templates. So there are other HSM or InventorCAM webinars available to you on our website. To focus now on defaults and expressions, some of this might be a repeat, but it's worth talking about. When we talk about defaults, it's common for people to want to change a value. For example, if I go to the passes tab, and maybe I should slow down. Here is an outside profile on this part that has multiple passes and depths of cuts and so forth. If I double pick edit that, and we go to the passes tab, you'll see here that we have the roughing passes switch turned on, and here is the maximum roughing step down, and here is the roughing overlap. And a lot of times the question is, where does this value come from? Okay, you can come in here obviously and change that to really anything that you want, and it will stick. Okay, or you can also right click on this and recall and reset it to the built-in default. So again, right click, you get a little sub menu, and that menu appears really on any field that you choose. So where did 0.5 come from? If we right click on this and click on edit the expression, which you can also hotkey with an F2, you'll see that the field for the roughing overlap is actually calculation of the maximum step down times 0.5. Simple. If I change some step down, the roughing overlap will always be 1/2 of that. You can change these. For example, times 0.6. Some step down is times 0.6. If I click one time, it gives us that value. So a lot of times it's how did you know maximum step down? How did you know to type that? Or how do you know where that parameter is being controlled or where it comes from? Using your mouse, we know that we can put our mouse in a field and get pretty elaborate and really well done help system from the Autodesk CAM people. If you take your mouse and put it in a field again, except this time hold down the Shift key, you get more information, and you'll see that this field is actually the parameter name maximum step down. And I've changed the overlap default, Shift, put my mouse in that field, and that's the roughing overlap, which is actually the maximum step down times 0.6, and the default from the system is times 0.5. So this is a great way to help you make these fields do what you want. And as mentioned earlier when Clayton did his presentation, and also something in our training classes, if you right click on this, you can now make that your default so that you don't ever again have to tell HSM or InventorCAM that you want your roughing overlap to be 0.6 times your maximum down. And the make default, you'll find that everywhere. You know, you can go into front face operation, go to the passes tab, and you can right click and make that a default. You can change stock to leave, and you always want to leave 5,000 stock. You can type in 5,000, right click, and make that the default. And now every time you do this operation and you have stock to leave, it'll be 5,000. Really nice way to do that. When I get into milling, there's another one that I'll show you if I remember. But one of the things that we run into, if I do a hole, a cycle drill, here I'm doing an axial hole. Drills in and drills out, okay? If I do that axial hole, we do have instances where I would like for my cycle type to actually be defaulted to chip break. I'm always dealing, especially on axial or some of my parts, I always want to do chip break cycles. And if I go and do a new hole operation or a drill operation, the cycle is set to drilling rapid out, and I got to come in here and change this every single time, and I don't want to do that. So on that webinar that Tad was showing us, he said we can change the defaults. So we go in here and we go to the cycle and we change it to chip break, partial retract, and we put our mouse here and we right click and nothing happens. So the thought is, well, bummer, we can't change the defaults on our drop downs. And that's not true, but it does require a different technique. When you edit and select an operation, double pick edit takes you right into that operation, right? And you find that's AutoCAD, Inventor, whatever you want it to be. Double pick edit is your friend. If you select the operation and instead right click, you get a submenu. And you've probably already all seen this if you're using the software now. But one of these submenus is compare and edit. And compare and edit allows us to pull up a dialog box, and we're looking at the actual hole operation. And I can, now this is a long list, kind of confuse you, maybe be a bit overwhelming, but I'm going to search down here for the cycle. There it is, there's the drilling rapid cycle, and I can change, remember I'm doing an edit. So I'm changing this operation to a chip break partial retract, but I'm not done. In the compare and edit dialog box, I can right click on that and make that the default. And now hit OK. So now if I do another new, completely new drilling operation and go to the cycle, my default is the chip break. So again, quickly, in a field that has a number, a box that you can type in, you can set those as the default and change those expressions and set those as your defaults again. If you want to change a drop-down, you have to right-click and go to compare and edit and change the drop-down in this field. Make that the default, okay? So just a little tip there. And we're all about setting defaults the way we want them, right? In the Inventor environment, there is a marking menu, and I'm not sure if you're familiar with that term or not, but it's an on-screen menu that you might see a lot when you're working from within the Inventor environment. We can move that or customize that in HSM also. And that's this little guy here that pulls up on your screen. And I just did that with a right mouse click. I'm going to go to a different file. And the purpose here is to show you that I'm in an assembly environment. When we go to Inventor, under Tools, there is a Customize option here that you may or may not be familiar with. In here, we can change and customize different things. Please use caution. It's very difficult to help clients that mess up their customization other than asking them to just bring back the defaults. But on the far right, we have the marking menu. I'm in an environment. If I do the sub menu, I can go to Add Control plus a right-click menu. And this is empty. I can then search for different operations, and it's giving me both Inventor and InventorCAM operations, okay? So I can click on this button here, and it's probably hard to, it may be hard to see on your screen, but it is slightly blue compared to the others. And I can add 2D adaptive, 2D contour, 2D pocket. How about 2D profile? I can click on this one, add simulation. Make sure that you get the one that you want because there are multiple simulations, and that's the InventorCAM simulation. I'll pick on this one, do a setup. You know, you can do whatever you want. And if I put my mouse there, that's the InventorCAM setup. And then I might do one more here. Call this holes. Hit apply. I'm leaving that one open. Okay. And now over in the CAM environment, at the assembly level, right, we can go and control right click, right? There it is. Control right click, and then you will change. I've changed my marking menu so that I can quickly access with the mouse different menu choices that I've chosen with a control right click. So one more time, tools, customization. You do need to make sure that the environment that you're in. So if I go to a part, and go to add control, right mouse click, you can see it's blank. So if you want it both on the part and the assembly, yes, you'll have to do it twice, or you can export and import also. Probably just enough there to confuse you. Hope not. Touch surfaces. This is a critical function that's often missed, and we run into this a lot when we're doing surfaces. So here I am back within the CAM environment. I have an assembly in front of me that has multiple piece parts on it, primarily fixtures, and then this here is the piece part to machine. Some of you may have seen this file already if you've done any surface or 3D training with us. It is one of the files that we like to use during a training environment. And here we have adaptive operations that are roughing out the guts of that part. We have some horizontal operations here that are going to finish any flat surfaces that it might find. We have a contour operation, and this could be probably another webinar on surface machining. But right now we're going to focus on touch surfaces. I also refer to them as check surfaces. Maybe that's old school, but you saw my gray hair. So here is a parallel operation. And you go, well, does a nice job of parallel machining the inside here that we've left behind, but it's also machining the top of the part and also this flat that we've already done. Now, what is common is you come into the parallel operation and you might go to your heights, and for the top height of the parallel operation, I can change that to be the model top and just push that down maybe a couple thou. Let that process, and it took care of that flat up here, but it's still rolling around the edge. So rather than struggling with this, a very simple thing that you can do, and again, often overlooked, is on the geometry tab, down at the bottom, there's a checkbox that talks about avoid / touch surfaces. And what this is this checkbox allows you, or allows me, to go out and tell the software that when you're doing this parallel operation and around the silhouette that we're working with, I want you to avoid this surface, and this surface. When I hit OK, it will go ahead and parallel all the operations that it can and avoid the top and this flat machined earlier. So you can use the these touch surfaces to basically tell the software to avoid or don't worry about surfaces on your model. For example, here is the pencil mill that is coming in and machining out some very small areas. But again, the tool is doing what we've told it to do. It's rolling up and around and hitting the top. If we face milled this, we're probably good, but you know how, a tenth can make a difference, right? And things like that. And when you roll around up here, there's a chance that you could put a little line of that face. So just a repetition here, we'll go back into this pencil mill under the geometry tab, and I'll do, again, tell this operation to avoid that and to avoid that, and hit OK. And now it no longer rolls up on top of the part. Depending on the piece part and your tolerancing, you may decide that there's a certain area. For example, we have 3 slots here that we're machining. This could be considered perhaps just a clearance filter or a fillet, sorry, and this is a clearance fillet, but something important's going in here that has a tighter tolerance, okay? So what we'll do, and again, the focus at this point is on touch surfaces, is I'm going to take that pencil mill that cleaned everything out, and in addition to avoiding the 2 top planes, I'm going to ask the software to also avoid these surfaces here. And the reason being is that I'm going to come back later and take care of those. So I'll hit OK. And then the pencil mill operation machines everything but what I told it to with the touch surfaces. Now let's go and let's focus again more on this slot. I want to use the same operation type. So I'm going to pick on the pencil mill and I'm going to right click on this, and we can do a copy and paste, perfectly legal, perfectly acceptable, or we can do a duplicate. You can copy and paste. Let me back up. Copy and paste and duplicate basically behave pretty much the same within the same file. Copy and then paste later, you can actually do from one file to another file. So I could take operations from one file, copy them, and then go into a brand new file and paste those. Duplicate doesn't do that. Duplicate is within the file itself. So I'm just going to go ahead and duplicate this pencil operation. So I have 2 of them now. I might change this to say O-ring so that I can more quickly distinguish between the 2. Now it duplicated everything, all right? So speeds, feeds, tools, step overs, geometry, check surfaces, all that good stuff, everything. So I'm going to come into this new operation that I just created, and we're going to double pick edit this. And on the geometry tab, I'm going to basically tell it to forget everything that I've told you before in the previous operation. So I now am going to basically machine everything, turn that off. But what I want to try to explain, and I struggle with this a little bit, so bear with me. There is a slash between the word avoid and between the word touch. So what this checkbox does is it allows us to avoid certain surfaces within an operation, just like we did before. We avoided the top, we avoided this O groove. It also can be switched to tell the operation to only focus on the surfaces that I select. So it's somewhat of an either or. So by turning on this checkbox here, the operation is only going to focus on the surfaces that I pick or the surfaces that I tell it to. So I'm going to turn this on. And now with the blue lit up, I can go out here and pick this, pick this. So with the touch surfaces checkbox on, this operation is only going to touch those surfaces. There we go. So with the first pencil mill and also with the parallel, I use touch surfaces to tell the software what surfaces to avoid. Okay. With the O-ring, I told the software with this checkbox to only focus on the surfaces I pick. This button here, it's awesome. Use it quite a bit. It can avoid surfaces that you pick, or it can touch only the surfaces you pick. And that's this checkbox right here is the key to that. Now you're probably filling up Caitlin's or Clayton's questions, but keep firing them away, and we should have some time here at the end. Manipulating the tool orientation is important in both milling and in turning, and we're getting into an area here where we can use one setup and have different tool orientations versus creating multiple setups. In a turning environment, we're going to find the manipulation of the tool to be very handy when doing axial drilling on the end of a piece part, or if you have a lathe that has live tooling capabilities. That might be a buzzword that you're not familiar with, but live tooling on a lathe basically gives us another axis and another spindle where we can turn parts, but we can also machine on them. In milling, it can be helpful also on tombstones, indexing, where you might have a table that will allow you to index, I always say like the four sides of a box. You could machine the four sides of the box in one setup. Well, let's go ahead and hit that real quick. We'll go back to my radial part. So we're a little bit familiar with this piece part here. And we have a lot of different operations on it. But what I'm going to do is I'm going to go ahead and just delete some of these operations, and we'll start from scratch on them. So at this point, what I have on the screen is basically tool path that is going to turn and face this piece part. The part does have other features, though, that we need to deal with. And we have a lathe that's pretty sharp to allow us to complete this part all on that individual machine rather than taking it to a mill to do these. This is where the tool comes into play. I'm in the single setup, and one thing to point out on a lathe is that the z-axis is typically going down the center, and then the x-axis is slicing through the part. So in a two-axis lathe, almost in all cases, we're basically machining in the z-x plane. Why is that important? When I do the axial hole, I'm going to go to a drill operation. And let's go ahead and pick a tool. And by default, you'll notice, by golly, that tool showed up right where I want it. Piece of cake, can of corn. And that's because it's important to note that the tool vector, or the tool axis, is always looking down Z. So when we deal with tool orientation, what we're dealing with is manipulating the Z-axis, okay? So for axial drilling, in this case, when it's on center, You shouldn't really have any trouble with that. I'll go to the geometry tab here, pick that hole face. I might go ahead and make sure the cycle is what you want it to be. And the display, the graphics display within the software is awesome. So, you can turn that part and you can literally see the 118-degree angle here of the tool or whatever it is that you've defined. And you can make a decision on the geometry tab if you do want that tool to go all the way through. I'm sorry, it's the heights tab, drill tip through bottom. By clicking that, that your display updates, and we'll hit OK. So real quick, we were able to face, turn, and now drill this part. So let's use that basic simple approach for this side hole. Again, single setup. I'm going to go ahead and do another drill operation. I'm going to pick a different tool. And I turn the shank off on this just for visualization so it doesn't really get in our way. So I'm going to select this tool. Under the geometry tab, we have tool orientation. I'm going to turn that on, and I'm going to tell the software that select the Z-axis, plane, and X-axis. And you do have other choices here, okay? So you can check the Z-axis plane and the X-axis, or the Z-axis plane and the if you have a part with sharp edges, you can control which way is X and which way is Y. This orientation worked out pretty darn well, and you can see that by the Z-axis, but for the sake of showing the steps here, I'm going to go ahead and pick on this hole right here. And we'll go ahead and flip that Z-axis. And I can flip it here within the dialog, or I can use my mouse and flip it there. So I'm in the drill operation. I can now select hole face and pick on that. And we'll go ahead and drill that hole. Let me look at the end here. All right, I want to make sure we drill it all the way by turning on the drill tip and hit OK. So simulating these two puppies here, right, simulate. We are axial drilling the end of the part, load a different tool, and drilling that. I'll take this drill operation that we have, and I'm going to edit it because I have two holes, and by golly, they're the same size. So on the geometry tab, I'm going to go ahead and select this hole also. And one of the things that you'll find, and you may or may not like it, is that this single operation is controlling both holes. So on this hole here, I really want that tool to push through the part, okay? So on the heights, the drill tip is going through the whole bottom. I actually want to add through another 100 thou. But you'll see that while it does what I want here, it also does it here. So we'll cancel this, and we'll go ahead instead, and we'll duplicate that operation. So there's the drill, and this is a duplicate of it. And I'll double pick, edit this, hit the red X to delete that. The orientation, I'm purposely changing, so you'll now see Z's pointing a different way. So I'm going to go out on the hole faces. I want to pick this hole. And again, just to maybe some repetition here, I want the Z-axis to point down here. If you don't like the direction, just hit the arrow or use the flip. Hit this. I want the tool to drill through the bottom plus maybe another 100 thou. and select the whole face and hit OK. Mill turn on lathes, live tooling. I can now go and utilize my milling operations also. And some of this is post-processor. Well, a lot of it is probably, but I'm going to go ahead and do a 2D pocket. And we'll grab a milling tool. The Z-axis, again, is pointing in the right way for me, but if not, you turn on your tool orientation and you tell it which way you want the Z-axis to face. I can go to the pocket selection and pick this pocket, and I've now machined that. And then I can repeat that, duplicate that operation, and do the same thing for this pocket over here. Or what we can do is we can take that pocket, right? Because this drill went all the way through the part. Okay, so that's done. We'll take this pocket and we'll create a pattern out of it. And this will be a circular pattern around this axis. And I can control the operation type, and it'll make sense a little bit more here when I show you a milling part. But you can control the tool orders and the operations. Do you want it to machine everything on one side before indexing, or do you want it to index by tool? So you have some options there also. So I'll hit OK. And now that operation is under the folder for pattern. Okay, so here's the outside profile. If I take what we just did and simulate this, we now have our axial drilling, and it's a deep hole, so we're doing some pecking. We orientate and use live tooling to machine this part. And we're done. And we can post-process this. I'm just going to use a basic Haas mill turn. Right, this is where the rubber meets the road, right, is the G code. And up here at the top, we have our face mill. We have our profile. Here is our drilling. Nothing really fancy there, but G17 is the XY plane. This G code is dependent on the orientation. Q is for pecking on this particular machine, okay? Then we're going to go ahead and do the side holes, and here you'll see the C output, where it's locking the C axis and allowing me to drill 2 holes, right? Okay. The 2D pocket, the tool is loaded up. It's giving me the same C90, which I appreciate. And then it's machining that circular pocket, turning off compensation, and then here you'll see the C270. So here's the C90, and here's the C270. And we've just machined that whole part on a Haas with live tool. In a milling environment, it's very similar. And that's the beauty of HSM, honestly, is here I have nothing going on. I have a piece part that basically has a pocket and a side hole in it. This could be considered a horizontal machine. So starting from scratch, We'll go to the CAM environment and we'll create a setup. And you'll see how it put the stock by default around everything, right? I'm in an assembly. The software at this point does not know what part I'm machining. So we'll use the model selection function and tell it that I'm machining that part. I also want the stock to be a relative cylinder, and I'm not going to have anything on the side, but we'll put a little something on the top. Now, the orientation of this is right at the front, which is fine. You can dial that for machining, and then when it would machine basically with the same XY values, honestly, around the part. But what we're going to do instead is I'm going to define the origin to be down here. Okay, so it's right through the center of that tombstone. So this is an important factor based on your machine, is making sure that the setup is set up the way you want it. So now that I think I have the setup where I want it, I have my stock ready to go. Got my model, my origin, everything looks good on my end. I'm going to go ahead and hit OK to that. And then we'll go ahead and do a face mill operation. And I'll pick this face tool. And I can see right away that the tool is indexed how I want it. Yeah, it's down there in a little bit, but the origin's down there, all right? So it's got to put it somewhere. So that's where it starts out. The geometry, I can see that it found the silhouette of the piece part for me, so I'm a happy camper there. On the heights, the bottom height is the top of the model, so I'm really good to go here for a face mill operation. Man, time flies. I'm not going to bore you with too much simulation. So let's go ahead and now do just a 2D pocket within the same setup, right? We'll grab that. Geometry, pick the bottom of the pocket, right? For you experienced users, that's because at the heights tab, the bottom of the operation height is the contour that I picked. So I can basically say, okay. And I've just machined that pocket. I do have a hole over here I have to deal with, so let's go ahead and do the drill operation. And we'll pick a drill. And when we go to geometry, I want you to note that with my mouse here, it's not letting me highlight that hole. And that's just a little visual indicator that your Z-axis is the wrong way, right? I mentioned earlier the tool automatically points down Z. So again, we have to turn on the tool orientation and tell the software that the Z-axis is actually pointing down that cylinder, and I'm going to flip it. I might also tell it that the X-axis is along this edge. Sweet. And then I'll pick these hole faces, and now you'll see it lets me highlight that. And we'll hit OK. So this single setup is going to go ahead and face mill one part. And man, I'm going to go ahead and show this to you anyway, even though we're running out of time. You can, on the setup, you can copy or duplicate an entire setup. So now I'll take this setup and double pick edit it. Okay. The model, delete, is actually this piece part. The orientation of the Z-axis is perpendicular to this. And the X-axis is pointing this way. Hit OK. The origin, same spot. OK. Now all of these operations are red, and that's because they need to be regenerated. And notice, please, that their selected geometry is on this part and not the piece part we're working on. But quickly, I can come into the face mill operation, double pick, geometry, found it, okay. I can come into the 2D pocket operation, double pick, edit. The geometry is that old geometry. So I'll unselect that and pick my new pocket. Pick my new pocket. I don't need tool orientation on now because my setup has oriented the vector. Okay. And on the drill, see how it's back on the old part? We'll go ahead and double pick, edit that. And on the geometry, the tool orientation, I'll deselect these, pick this Z-axis here. X actually looks pretty good if I just flip it, and then select that whole face and hit OK. So you can duplicate complete setups. So we can machine that face. But I'm going to delete this setup. And real quickly, and I apologize for flying here, I'm going to go ahead and create a pattern. Select these three operations, create a pattern. It's going to be a circular pattern. The axis that we're going to flip around is that puppy right there. And now you can see it showing up in two places, right? Before those guys. And this is where this may come into play more, is the order by tool. Or do you want to preserve the order? Preserve the order will machine the entire part with the multiple tool changes and then index. Order by operation and order by tool will do the face mill, index, face mill, index, face mill, index. And again, and Ashley, don't kick me off yet. Hopefully this doesn't just end. I need a few more minutes, please. Post-process this. I have an Okuma down here, the B-axis. And right, it's the B-axis because we're rotating around Y. So we'll post this out. All right, and maybe for quickly, I'll just go up here and say, hey, find me the B's. There's B0. Hopefully you can find it on the screen here. There's B90. And here's B180. And then real quickly, I want to finish this up. I do want to talk about a spun profile. Now, this won't take long, so apologize here for running over. I know you are busy. A spun profile is another one of those hidden things. If I go into this traditional turning part that has some milling operations on it, and I have a setup defined, and note the x-axis on this is pointing right up through that cutout. If I do a turning profile, if you've got a good eye, most of us are over here focused on the browser, right? But if you got a good eye, you'll see right away something's up. And if we okay that, we just cut the top of that. And the reason that I kind of mentioned that earlier was the setup is going through the the XZ plane on a lathe. This is where the spun profile comes into play. The software is cutting a plane through X and Z. Snap, just took a knife and cut right through that. And that's what we were left, is this top face. The spun profile, you'll find it in setup down at the bottom under model. Turn that on and hit OK. And now this operation will behave as you would expect. Now it is coming down there a little bit, and that is because we are allowing it to do radial and axial grooving. Turn that off. Okay. So watch the spun profile on milling operations. One more and I'll be done. I'm going to delete that. I'm also going to go over to the model and I'm going to unsuppress this. And all it is a hole that goes right through the part. And we get hit with this a lot from people that are getting an error. If I do the profile operation now with the same tool, and spun is off, all right? Oops, cancel. Go back into the setup, and I want to turn spun off. Simple profile operation, we've done it 100 times. Pick the tool. We're not looking at the graphic screen, but if we are, and we'll go ahead and OK this, and by golly, we got no tool path. Well, man, I've done a profile operation 100 times. When you expand these, you can right-click on them and go to Show the Log, and it tells us here that the operation for the turning profile is actually 2 or more parts, and it can't do it. And that's because this hole is going all the way through. So again, we'll go into the operation, turn on the spun profile, OK, and regenerate the tool path, and now it works. All right, I'm sorry that I ran over. That's what I had to show you. Are there any questions or anything that we have? Did we lose everybody? I hope I.
Questions have been real quiet, Tad.
All right. I hope I didn't do too much. I apologize for that. I just wanted to give you what I had and give you as much as I could to fill the hour, and actually information that I hope you find helpful. If there's no questions, and I'm already over time by 4 minutes, I think that'll terminate it. And Ashley, I don't know if you close this out or.
Yes, I can. Thanks, Tad. This will conclude our broadcast, but if you think of additional questions later, you can simply reply to that confirmation or reminder email that you received from GoToWebinar. We can get those to Tad or your sales rep to get your questions answered. Once again, if you could take a few moments to fill out the short survey, we would appreciate it. It will just pop up as we close down today. Thanks for attending, and have a great day, everybody.
Thank you.